Hey guys, welcome to a brand new video. In this video, I am talking about the C implementation of a doubly circular linked list. So if you have checked my previous video in which I talked about a circular linked list, then you all guys might already know what is a circular linked list. So if you haven't checked that video out till now by any chance, then you can always access the entire playlist in which that video is also present by clicking on the top right corner I button. So if you are going to see this video and haven't seen the previous one, then first of all check that video out and then you can come to this video to watch it entirely. Now before starting this video, I would like to inform all you guys that if you like my effort and want to support and motivate me in increasing the quality of my content and want to get some new information about coding, technology or any other stuff, then you can always subscribe to my channel and also give this video a like, as well as share this video with your friends who like this kind of content. And also shortly I will be making some gaming videos as well, so stay tuned for that. So now with that being said, without any further ado, let us jump into this video. So in this video we are talking about a doubly circular linked list. So basically if we add doubly to a circular linked list, then that basically means that we can traverse in the forward direction as well as in the backward direction. But forward and backward hold significance only in the case of a linked list. But if we add circular to it, then forward and backward basically means we can move both anti-clockwise as well as clockwise in the case of a doubly circular linked list. So for doing that we will need two pointers, but we have to define a node like this. So basically this is going to be the definition for our node. So inside the structured node we will have one integer variable named data, which is going to store the value of the data which is going to be present inside each of the nodes. And also we are going to have two pointers of the name next and previous of the type struct node. And also in this program I am creating one global pointer start, which is going to be the starting node of our doubly circular linked list. And now let us jump on to the main function. So inside the main function, as always, as I had shown you in the previous video also, we have two integers, that is choice and value. And also we have a menu based program which is driven by a while loop. So in the menu we have four options. The first one is insert, then we have delete, show and exit. So insert function is basically used for inserting any value or node into the doubly circular linked list. Delete function is used for deleting any node from the doubly circular linked list as mentioned by the user. And show function is basically a kind of traverse function which will let you see what all are the content present inside the doubly circular linked list. And exit function is used for exiting the menu based program. So first of all I am entering one value, that is the user will enter one choice based on the menu given here. So the case 1 corresponds to the insert function. So the insert function which we have taken over here is the insert into circular doubly list function. So it is taking two arguments, that is the address of the starting node of the doubly circular linked list and the value which the user actually wants to insert into that list. So now let us head over to the definition of the insert function. So the insert into circular doubly list. So inside this function, first of all we are allocating some memory or space to one pointer t of the type struct node, and then we are initializing another pointer x of the type struct node with the starting node of the doubly circular linked list, and then we are inserting one value inside the data field of the t pointer, and we are telling that t is pointing to a null pointer by writing t of next equal to null. And now we are checking whether the list is empty or not by making use of an if else clause. So if start is equal to null, then the t pointer is going to be our start as well as the ending node. So for that I am taking start to the position of t, and also making one self loop by writing t of next equal to start and t of previous equal to start. So basically t is pointing to itself only in a bidirectional manner. So the next of t is also start and the previous of t is also start. So that is what it basically means. Now inside the else condition, we are making use of an while loop. So this while loop will basically take us to the end node, that is the node just before the starting node of the circular doubly linked list. By making use of this condition over here, as you can see, and we are going to say t of next equal to start, t of next equal to t, and t of previous equal to x, and t equal to t to next, and x equal to x to next, and t of previous equal to x. So in this way we are creating one loop. So first of all, what we have done here is that as we had inserted the value as well as the next position of the pointer t, we are going to first of all create one bidirectional link between the t pointer as well as the starting node. So after creating that link, as we had already traversed to the end node of the doubly circular linked list, which is x, now we are going to create another bidirectional link between the x node and the t node. So in this way, t is going to get inserted into the doubly circular linked list. And after inserting, we are going to print insert success. So now the next function in our list is the delete from circular doubly list function. So it is also taking two arguments, that is the address of the starting node of the list and the value which the user wants to delete from the doubly circular linked list. So now let us head over to the delete function as well. So the delete from circular doubly list function. So inside this, we are initializing the integer found by 0, and we are initializing the pointer of type struct node y by the starting node of the doubly circular linked list, and another pointer x by the node present next to the starting node of the list. And then by making use of one if condition, we are going to check if the node present next to the starting node is equal to null or not. So if that is so, then we are going to print data not found. And we are making use of another if condition, and we are going to check if the data present inside the x pointer is equal to the value which is passed by the user or not. So this value over here, as you might have already guessed, as I told you all in the previous video, this is basically the after value, that is the value present after the value which we have to delete. So the value present before this value, that is the value inserted by the user, is actually going to get deleted in our case. So we have to delete the value present before this after value. So for that, we are going to check if the data present in the x node is equal to value or not. And then we are going to do some coding over here. Like we are going to write x of previous equal to y of previous, and we are moving y to the previous node. And we are going to move start to the x node, and we are making one link by writing y of next equal to x. And as we have found the value, as we had already found the after value which was given by the user as input, we are going to assign the value of 1 to found, and then we have to print deleted. And then we can return or exit from this function, which will take us here inside the case 2. And now we also have one while loop which is going to check for whether the value present inside the pointer next to the x pointer is equal to the value or not. So if it is so, we are going to assign the value 1 to found and break from the while loop. And inside the while loop, we are also initializing or assigning the pointer x to the pointer y, and we are incrementing or moving the x pointer to the next place or the next node. And then if found is 0, that is we haven't found any value entered by the user as such, then we are going to print data not found and return back to the case 2 of the switch case. And then after all these conditions over here, we are making a connection between x and y by writing y of next equal to x of next. So basically y and next both are going to point to the same node, that is the node present next to x, and we are moving x to the next node by writing x equal to x of next, and we are making another connection because it is a doubly circular linked list by writing x of previous equal to y, and then we are going to print deleted. So these were the two functions, that is insert and delete, from a doubly circular linked list. And now the third function is the show function. The show function is going to traverse the entire doubly circular linked list and show all the values as we had done over here. But as I mentioned in the previous video also, we are going to traverse the entire list, but as it is a circular linked list, we have to print one value first and then check for whether we have reached to the starting node once again or not. So it is going to get started from the starting node and traverse all the way until the last node just before the starting node once again. So because of that, we are making use of the exit control loop, which is the do while loop. So in this way, we are printing the entire W circular linked list. So this was the entire code. So now first of all, let me run this program, but before running this, I will compile it first. So as you can see, it is successfully compiled. Now I will move to the bigger screen and zoom in a bit so that you all can see. Okay, so the menu has appeared. So first of all, I'm going to insert some values into the W circular linked list. So for instance, let me insert 12, and then I'm going to insert 23, followed by 34, followed by 45, and then finally 56. So now let me see what we have inside this list. Okay, so this is the entire list right now, and now if I delete something, then I have to insert the after value. Let me delete 23 first. So for that I will have to insert 34, and now let us see what the list actually looks like right now. So as you can see, 23 is successfully deleted, and now if I want to delete 45, then I will have to insert or put 56, and now let us see what the list looks like. So 45 is also deleted, as you can see over here, and now if I delete 12, then I will have to insert 34. Now if you remember, then in the previous case, in the previous video in which I discussed about a circular linked list which was not a doubly linked list, we couldn't delete the starting node because we were taking it as a reference point. But here I want to delete 12, which is the starting node. That is the node which we had inserted into the list before all the other nodes. So now if I delete 12 or want to delete 12, then the after value for this case is going to be 34. So as you can see, we are not getting value not found or something like that. We have basically deleted 12. So this is because of a certain change which I was able to make, because it is a doubly linked list and I was able to harness the power of the previous pointer as well in this case. And now if I print the list, then you can see 12 is successfully removed or deleted from this doubly circular linked list. Now if I want to delete 34, then I can also do that, because now 34 has assumed the starting position, that is, it is the starting node right now. And because of that only, the show function is printing 34 first, because it always starts from the starting node. Now if I want to delete 34, then I will have to insert 56, and then if I print, then only 56 is present. Now if I want to delete 56, then what will happen? You have already seen the code, then can you guess? So now let me show you what will happen actually. So the next node of 56 is 56 itself, because it is a self-iterating loop, as you can see. So 56 is deleted, but it is actually not deleted, as you can see over here. So there is a glitch in the code. So basically, you will have to have at least one value present inside the W circular linked list according to the code which I have written over here. So because of that, we are not able to delete the starting node present at any instance if the other nodes are not present. So that's it. That's the C implementation of a W circular linked list. So that's it from this video, guys. I hope you enjoyed it. If you enjoyed, don't forget to like this video and share this video with your friends, and also press the red subscribe button and turn on the bell notification as well, so that you never miss an update. And also tell me in the comment section what kind of video you want me to make for the near future, and how you want me to improve my content and bring some varieties in it. So I will meet you next time in some fresh videos. Until then, stay tuned and keep exploring.